Hello everyone, welcome to my YouTube channel. This is chapter 4. We are going to find the land cover and we are going to identify the curve number for HEC-HMS. Here you can see again my quantum GIS, my bassin with the subbassin and with the S3 satellite imagery. Principally we have, as far as I know, 4 ways how to identify the land cover. One of the easiest way, but this is working only for North America, is through a plugin called Curve Number Generator, but this only works for the United States. Therefore, for us, not very interesting. Another way that might work properly is that you develop yourself your shapefile, but this works only if you have a relatively small bassin and if you know very well your area, and additionally if you have a very good high resolution imagery, which is not the case for our situation. Then you have another possibility that's only good for Europe. You can download the Corine land cover map. That's a geo package of 10 meter resolution. Here you can see the extent of the coverage of the Corine land cover, and for the rest of the world the land cover from Sentinel-2. In our example we are going to use the Sentinel-2 land cover imagery because this might be a better solution for everyone. This land cover imagery has 10 categories, like you can see: water, trees, grassland, flood vegetation, wetland, crops, scrubland, built area, bare ground, snow and ice, and cloud. How to proceed? Just click on the link that I give below the video. This link will automatically open a site called Land Cover Downloader Map. It will take some time and then the world will appear. You have to zoom in on the right tile where you are interested to. In this case I am interested on this tile. As you can see, it's a big tile. We have part of Italy, Switzerland as well. You click on the tile. Tile is going to be selected and you download the tile. In my case it is 119 megabytes. It's a TIFF file and it is going to download. Takes a few minutes. Once the tile is downloaded, just take it and put it on the right location. It is on the download folder here, 185 megabyte. I cut it and I put it on HMS tutorial. I can put it on the terrain. At this point I can open this tile with quantum GIS. I go to open data source. It's a raster. I browse to the location where I've just pasted my tile. That's this one. And here we have our terrain file. You can see here we have as well automatically the legend, but we don't know exactly what those colors are meant. And additionally, this file is too big, therefore it makes sense to crop it in order to have a better speed when you work on that. So how to crop? I go to raster, I go to extraction, I go to clip raster by extent, and I choose the right one. This one, clip in extent. Use map canvas and run. Now I have my land cover but much smaller dimension. The original land cover I don't need anymore. I remove it. Be careful because this is a temporary layer. Now you can see it's just the area of interest. Not everything is much smaller. But of course you need to save this raster file somewhere, therefore we export it. We save it as a GeoTIFF UTM-32. I call it land cover. Now I have saved it. Okay, is this one the original temporary layer is not necessary anymore? I remove. Now let's put the legend to this land cover. Click twice. Paletted, unique value, classify, and here we have the color and we have the labels. Apply. Okay. At this point you have to convert this raster file in a shapefile polygon. You just go to raster, conversion, polygonize. You choose the raster file that you want to polygonize, land cover Valcamadra. There is only one band, so you cannot make it wrong. Here you write the name of the field that you want to create. It's the number that it's already in the raster file. I call it in this case DN. That's it. We run it. It might take some time, but fortunately the file was cropped, so there shouldn't be that much long. Close. Here it is. It's a temporary layer. The original raster file we don't need anymore. I can remove it. It's vectorized that I want to make it permanent. I right click on it and click on make permanent. So ask me the place to save it. It's a shape file. I call it land cover shape, and the rest is fine. Click OK. It has not been uploaded, therefore I load it on my qGis. It's a vector. I go and take it. It's land cover shape. It's here. Add. Okay, that's fine. This I don't need anymore. Fine. Now I can have a look what we have inside on this land cover shape file. On the attributes table, you can see you have this value, which was the type of terrain. Now what we have to put, we can put a new column saying what does it mean in the number, and the second value saying what type of curve number it has. Below the video you will find a small script that will help you to automatically insert this table. If you remember, number 1 means water, number 2 tree, number 3 grassland, number 4 wetland, and so on. Therefore I just copy this very short script. I will just go on this icon, which is the field calculator. I insert this one here, and here it says when you have dn equal 1, then write water. When you have dn equal 2, then write grassland, and so on. Here I have to give output field name type over, then it's a text of at least 20 characters, and now it's fine. Now you can click OK, and I create a new field. Let's see what happens. Okay, you see now here we have water, 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 and this can be useful when you make the legend. And now I have to create another column that links this cover to a CN, to a curve number. In the manual you can find a lot of information about the SCS curve number loss model. You can find the basic concept and equation. You can find the definition of the soils group. Group A has low runoff potential and high infiltration rates, for example sandy soil, going up to group D, who has a very high runoff potential and very low infiltration rate. In my case, since I am in the mountains, I have very tiny soil. We are choosing our land cover over a soil between C and D. You can see based on the soil type you can give the CN number. Of course this is an estimation. We have only 9 type of different soil cover, and here there are plenty of possibility. Definitely your common sense and your feeling play a big role on this estimation of the value. Once you have estimated those values, you need to put them on the qGis. Again, you can open your qGis where you have your soil map. If you open the attribute table of the land cover shape file, you just see here the 3 column, the ID column, the DN column that has been created before, and then the legend column where it says what type of land cover we have. Now we have to insert the CN column. So we have to define what type of curve number we have based on the soil and based on the land cover. We click again on the field calculator and we take this expression that you can find below the video. This expression is the definition that I have given to the different land cover type. For example, if I have number 1, which is water, then I give a curve number 100. If I have number 2, which is tree, then I give a land CN23, and so on. This, like I was saying, it's your estimation, and of course depends on your knowledge of the location. So you copy again this expression and you insert it into the calculation. So again we can give the name of the output field, which is called curve number. This time the result is a whole number, integer. The length 10 is fine, and the column should appear. You see now automatically for water I gave 100, for tree 73, for grassland 79, scrubland 70, bar ground 91, and so on. I save my layer. Now we have a land cover shapefile that contains type of land cover, name, and CN number. But we have a small problem. Now I have opened again my qGis. I have displayed the land cover shape. I have changed a little bit the layout. I have given some color that makes more sense. For example, water is blue now, grassland is green, and so on. Now you can see I have a problem. I have in some basin, like the subbassin number 13, for example, some ice, I have some rocks, I have some grassland, and as well some trees. So for each of these cover I have a CN number, but what would be now the whole number for the subbassin 13? It should be somehow a middle value between all these trees, and in qGis you have a way how to create this middle value. In order to create a middle value for each subbassin, you need to re-rasterize your land cover shape. In order to re-rasterize your land cover shape, you go to conversion and rasterize. You get this mask. Here you need to choose land cover shape. Important, you need to choose the born in value. In that case it is the curve number. Here nothing. The output raster size unit must be pixel. Here you need to put the resolution. If you put a very high number, the rasterization will take a very long time, so you should put a number that somehow matched with the resolution of your land cover shapefile. In my case it is 10,000, but it might be different for your case. The same here, 10,000. The extent you can make the map canvas, and the rest you leave it like it is and you click run. It might take some time depending on the size of your subbassin and on the speed of your computer. Fine. You see here that you have a band ranging from 100 curve number to 70 curve number. If you click the info tool, you can see on the right left the curve number. Here is 100, here is 70, here obviously it's water, should be 100. That's fine. If you want to check the resolution, just zoom in a lot. For example, here we can zoom in. We can see this is the resolution of our land cover shapefile. So we have 1 pixel of 10 meters, and here is the resolution of our rasterized land cover. We have exactly the same resolution, so we didn't lose any type of information. Now we have the rasterized land cover for all the region, but we need to know the average curve number for each bassin. And in qGis there is a way to do that. You need to go on the processing toolbox, then you can go to raster analysis, and you can go to zonal statistic. Zonal statistic is a logarithm that calculates the statistic of a raster layer for each feature of an overlapping polygon vector layer. It means it will take the statistic for each polygon for each subbassin. So what to do? You have to select the subbassin as an input layer, then the newly developed rasterized land cover raster. The band is anyway only 1, and here you have to choose the mathematical expression. We want to have the medium value of the curve number, not the sum, not the count. So we just click on mean and we click on run. Again, this process might take some time. Finished. I close it. Now we get a new temporary layer called Zonal Statistic. Let's have a look what we have inside. Clicking on the attribute table, and there you can see we have all the subbassin, and here we have the mean, means we have the curve number. Here, for example, we have 70. It means in this subbassin number 21 we have only one type of land cover. Let's have a look on the subbassin 21, which is this one. If we put the land cover map, yes, it is green. It is Grassland or Scrubland, probably Scrubland. Let's see if it is matching as well with the Esri satellite. Yes, actually it is. We don't have forest here, we have only high mountains, nothing else. That's fine. So this can be really only grassland. Now we have our CN number for each subbassin. At this point we have to insert our curve number into HEC-HMS. To do that, we have first to export the data through an Excel file. We go to Zonal Statistic, you right click on Zonal Statistic and you export. Save features as, and we don't export it anymore as a shapefile, but we exported it as a CSV file, comma separated value. We can give the location. I would suggest to have the same location. It means HEC-HMS tutorial terrain, CN number, subbassin, and OK. I open now an Excel file and I import the saved CSV file. Let's see. It looks good. Yes, we have the mean separated. Finish. Okay, here we have now our subbassin, and here we have the CN numbers. Now I can copy this CN number. Just be sure that the subbassin are displayed alphabetically. I copy the CN number. I go into my HEC-HMS. I go into parameters, loss. SGS curve number should be black. I click on that, and here you can see that you can import your CN number. Be sure that the subbassin is displayed alphabetically. Fine. Paste under curve number. Here now you can see you have your curve number. The rest you could actually add manually the impervious percent. If you know it, it's very difficult to estimate the percent of impervious land. And additionally, you could also insert manually the initial abstraction, but we don't have this estimation as well, therefore I don't insert it at all. And you click apply. Here we have. At this point you can check by each subbassin you have a curve number inserted. This is the end of part 4 of this tutorial. Do not forget to save your Quantum GIS, do not forget to save all your shape files, and if you are still listening to my voice, it really means that you enjoy this tutorial. Don't forget to like it or subscribe to the channel. Let's meet for the next tutorial where we are going to speak about the lag time. Thank you very much for